Hi learners, welcome. In this video I am going to explain crystal field splitting of two more complexes having trigonal bipyramidal geometry and pentagonal bipyramidal geometry. Let us see. As usual, in order to know how the metal d orbitals are undergoing splitting, first we have to know how the ligands are approaching towards the metal in each of the complex. So in order to know how the ligands are approaching, we have to know about its geometry. So let's start with trigonal bipyramidal geometry. Here metal is surrounded with 5 ligands, and if you arrange the ligands around the metal, 3 of them are occupying a trigonal planar shape in xy plane, and 2 ligands are occupying above and below this trigonal plane in z direction. If you draw the axis, this is z axis, and these two are the x and y axis. And now let's see how the ligands are approaching in this complex. In z axis there are 2 ligands which are approaching on the axis. Okay, and the remaining 3 ligands are lying in xy plane, and they are not approaching on the axis, they are in between the axis. So we came to know after knowing its geometry, and when you draw the axis, 2 ligands are approaching in z axis direction, 3 ligands are lying in xy plane, means they are approaching in between the axis, in between. Now with this knowledge, as well as by knowing how the d orbitals shape, we can easily understand the crystal field splitting of this geometry. You know, there are 5 d orbitals of the metal. 3 d orbitals are having lobes in between the axis. They are dxy, dyz, dzx, and 2 orbitals are having lobes on the axis, that is dz square having lobes only on in the z axis direction, and dx square y square orbital is having lobes on x and y axis. So these are the 5 metal d orbitals. Now let's see crystal field splitting of d orbitals in this geometry. This is energy axis. As usual, 5 metal d orbitals of free metal ion as well as in presence of spherical field. Now after this, if you observe out of all 5 d orbitals, who will experience more repulsive forces in this case? Here if you see, 2 ligands are approaching on the axis in z axis direction. So whose metal d orbital is having lobes on the axis and in z direction? Dz square. So out of all 5 d orbitals, who will experience more repulsive forces from these 2 ligands? That is dz square orbital. So dz square orbital occupies highest energy level because it gets more repulsive forces from the ligands. And after this, if you see, there are 3 ligands in xy plane. Even though they are not approaching on the axis, but 3 ligands are there in xy plane. The orbitals which are having lobes in xy plane used to get more repulsive forces after this. Who is having lobes in xy plane? dxy is having lobes in xy plane in between the axis, as well as dx square is having lobes in on the axis. So these 2 orbitals used to get repulsive forces after this. But the repulsive forces are very less. That's the reason why they are below the barycenter. You can see they are below the barycenter. What are they? dxy and dx square y square. So you can see it's a degenerated level. 2 d orbitals are present in this level. And after that, if you see dyz, the rest of 2 orbitals, dyz and dzx, they are having lobes in between y and z axis, z and x axis. Okay, and here no orbital is exactly approaching in this direction, but there are 2 ligands, 3 ligands in each case. So that's the reason why both the orbitals will experience same repulsive forces, but they are very less, and that's the reason why they occupies lowest energy level out of all. Who is occupying lowest energy level here? dyz and dzx. In this way, the metal 5 d orbitals of in trigonal bipyramidal field geometry they will undergo splitting into 3 different energy levels. One is experiencing very high repulsive forces and it is said to be destabilized. The remaining 2 are said to be stabilized. They are below the barycenter. Okay, this is the way of explanation of splitting of the orbitals in trigonal bipyramidal geometry. Now let's see in pentagonal bipyramidal. Next shape, that's pentagonal bipyramidal, where in this complex metal is surrounded with the 7 ligands. 5 ligands are occupying pentagonal shape and 2 ligands are occupying and above and below this. Now if I draw an axis, this is Z axis, X and Y. And in this case, if you see, there are 2 ligands which are approaching on the axis in Z direction. Okay, remaining 5 ligands are lying in XY plane. 2 are approaching, 2 ligands are on Z axis direction. And then 5 ligands are lying in XY plane. With this knowledge, we can simply write the splitting of d orbitals in pentagonal bipyramidal geometry. Let's take the energy axis. This is the energy axis and these are the 5 degenerated d orbitals of metal, free metal ion, and in presence of spherical crystal field. And when furtherly the ligands are approached towards the metal to form the complex, we will experience more repulsive forces here. 2 ligands are approaching on the axis in Z direction. So automatically the orbital which is having lobes on the axis in Z direction is to get more repulsive forces. Who is having again dz square. So dz square occupies the highest energy level. After dz square, you can see there are 5 ligands approaching in xy plane. So the lobes, the orbitals of the metal which are having lobes in xy plane is to get more repulsive forces here. They are dxy and dx square y square. But here if you see, their energy is higher, dxy and dx square y square. In the same way, here if you see, they are occupying the next energy level, but their energy is very less. They are below the barrier center. But here if you see, they are occupying above the energy barrier. Okay, because there are 5 ligands. Because of the 5 ligand repulsive forces, they get more energy in this case. And who gets least repulsive forces here? The ones that are having lobes in between YZ and ZX axis. So almost trigonal bipyramidal and pentagonal bipyramidal crystal field splitting is same. 5 degenerated d orbital of metal is undergoing splitting into 3 different energy levels, and one is dz square occupying the higher level, followed by dxy, dx square y square, doubly degenerated, followed by dyz, dzx. Again it's a doubly degenerated. But the difference is here dxy, dx square y square are having less repulsive forces and are occupying below the energy barycenter. But in this case, pentagonal bipyramidal, they are getting more repulsive forces because of 5 ligands in xy plane and they are above the energy barycenter. That's the only difference, and the rest of the thing is same. Hope you understand everything. Thank you for watching. Please subscribe.